Okay, namaskar, Hari Om. Good evening to all of you, and welcome to this session on 10th Standard Revision Series. And today we are taking the topic periodic classification of elements. Okay, now periodic classification of elements. I'll first just tell you what is a need. I know you have heard this a lot, many times, but I will still repeat it. Not so that you can revise, but so that I get into the flow. Okay, and you all can listen to it. So imagine now there are about 800 children in your school. Okay. Now all the children, when they come together in the morning, it's a big mess. Correct? Down at the assembly hall or in the basement, wherever it is. And then after that, what happens? All of you, when you're standing, I'm talking about the BC, before Corona time, okay, BC era. So then what happens? Once your principal, vice principal, everybody, once they all start walking in, then you all get organized into different rows, isn't it? So all of you stand according to your classes, according to your sections. That is, you all classify yourself. Correct? Now, this is something analogous to periodic classification. Okay. Now, how do you all classify and stand in different rows? Depending on your class and depending on your section. So like 10th standard will be at the back. So 10th standard A, B, C, D, whatever are your sections, right? And probably the KG children will be at the front because they all are chuntus. So senior KG A, B, C, junior KG A, B, right? They all stand somewhere in the front. So every one of you get classified into different places, right? Now, how are these places decided? These places are decided depending on your size, right? The chuntu ones will be at the front, then the taller ones will be at the back, and the tallest ones, which is you all will be at the extreme back. LLBs, lots of backbenchers, right? Now, periodic classification of element is also something similar. Okay. Now, what happened in the times of Eeyore, long back, not too many elements were known. Okay. But slowly, as more and more elements kept getting discovered, they felt there is a need to classify the elements. Okay. Classify the elements how? Classify the elements according to the properties, according to the number of electrons they contain, number of protons they contain, number of shells they have, and even sometimes according to the use. Okay. But itna electron, proton, and all those things they never knew at that time. So initially they followed the simplest rule for classification: metal, non-metal. Okay, those things that keep shining and when you hit them, they give dung voice. They all are metals. Those things, when you hit them, they become powder. They don't give any dung voice and they don't shine. They all are non-metals. Okay. And there were some which were shiny, but if you hit them, they will become powdered. That is, they had property of both metals as well as non-metals. So they were called as metalloids. Okay. This is how the classification was done early. But later on, what happened? More and more elements kept getting discovered. Then what happened? This metal, non-metal, metalloid, it was not fitting. Okay. That is when there was somebody called Dobryna. Okay. Dobreiner. Just correct me if it is Dobrei. I think it is Dobe, right? Dobereiner.
Yes.
Thank you. So, what did Dobryner do? He said, please give me just one moment. Give me a moment, please. I think classification. Once again, I'll just reshare my whiteboard. I hope you all can see it. Yeah, it's visible now, no?
Yes, ma'am.
Yes.
Okay, thank you. So what did Dobereiner do? He actually made everything into groups of 3. Okay, 1, 2, 3, 1, 2, 3. We all do that, na? Class dispersal. 1, 2, 3, 1, 2, 3, 1, 2, 3. This is exactly what he also did. Okay. He said, if I look at all the elements that we know currently, then there are every 3 element has got similar properties. So that is how he came up to this. LiNaC. That is what? Lithium, sodium, potassium. Okay. Then which were the other triads? Can anybody say? Unmute yourself. Go ahead. You have your textbook in front of you. Open your textbook and say, go ahead.
Calcium, strontium, barium.
Calcium, strontium, barium. Okay. Which one? Which is the next one?
Chlorine, bromine, iodine.
Yes. Chlorine, bromine, iodine. So like this, he kept making groups of 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Then he said that after every 3 elements, there is a uniformity in the properties. Okay. There's a uniformity in the properties, and that is why we can classify the elements into groups of 3. Okay. Then one main feature which he found was about the atomic mass. That was a main logic which he used when he was trying to make these groups of 3. Okay. Now, what was this atomic mass ka rule? What logic did he use? Anybody? Just unmute yourself.
The mass of the middle element equal.
So sorry, Kshama, I'm not able to hear you properly. Chinmay, can you try?
Increasing order of their atomic masses.
Yes, that is one point. Then, thank you, Chinmay. What else? Anaga.
Atomic mass of the middle element is the average atomic mass of the other 2 elements.
Yes. The atomic mass of the second element, when you arrange them in these triads, triad means Triad. Triad means group of 3. Okay. Just like how we say solo. Solo means only 1. Duet means 2. Triad similarly is groups of 3. Okay. So when you go to that triad, the atomic mass of first and third element, if you take the average of the first and third element, then it gives you the approximate atomic mass of the second element. Okay. This is the main logic using which he actually divided all the elements. Okay. Now, when he actually divided into groups of 3, he observed that the properties are also very similar. Okay. But then there was a limitation. Okay. What was the limitation?
It was only till calcium.
Yes. That was a big drawback. It failed to arrange all the known elements in the form of triads, even those having similar properties. Okay. So then Dobereiner was like, okay, I'm sorry, I tried, but it didn't work very properly. Okay. But the good thing was somebody tried. Yay. And then it happens like this, no? Like one person does something, there's a dominoes effect. Everybody starts doing the same thing. Correct? So this was also something like a dominoes effect. Then what happened? There's another scientist called Newland. Now he came up, and what did he do? he also arranged everything in the increasing order of atomic mass. Then he said, look at all of them. Now, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Then after that comes fluorine, sodium, magnesium, aluminum, SIPs. That is silicon, phosphorus, sulfur. He said, these properties of every 8th element is going on repeating. Okay, so hydrogen, Lee, Webb, C, no. Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. There are 7. Sa, Ri, Ga, Ma, Pa, Da, Ni. Then what comes after Ni? Sa. Right? The higher note Sa. So he said that goes back to fluorine. Now he said the properties of fluorine and hydrogen, they are very similar. When you arrange them in the increasing order of atomic mass, the physical and chemical property of every 8th element is a repetition of the first element. So he said it is just like music, the notes of music. Okay. After every 7th note, the first note gets repeated on a slightly higher pitch. That's all. So he said, this is very interesting. And he arranged a lot of elements like that, which were actually discovered at that time. Okay. And then what did he say? See, now this way you can arrange all the elements and they all are having similar properties. So classification has become easier. People accepted it. But then there was a drawback again. What was the drawback this time?
It was not applicable to every element. It was only applicable till calcium.
It was only applicable to calcium. That is only for the lighter elements. Okay, those first 20. He Libepsinov, Namgal6, chlorine, argon, Kirkat. So only the lighter elements could be classified in this way. Then he put cobalt and nickel. Both have got 2 diametrically opposite properties. Okay, he put both of them in the same group, or rather in the same box, same slot. Okay, so like cobalt and nickel, fluorine, chlorine, bromine, iodine, they all were grouped together. Now cobalt, nickel, fluorine, chlorine, bromine, iodine, they all are like completely different, right? Because fluorine and all these things, they all are halogens. Then another limitation was only 56 elements were there in nature. At that time, during Newland's time, there were only 56 elements. And he was like very confident, no more elements will be discovered. Only these many elements will be there. Okay, he was very confident. So he did not leave any space for the future. At that time, people just lived in the present. No, they were never futuristic. Nowadays, whatever we make, we think of the future and we make things, right? But at that time, the people were not so futuristic. So then when new elements were discovered, there was no place for that. So then after that came Mendeleev's periodic table. Okay. And that is a modern periodic table, noble gases table. But it's not the complete modern periodic table. That is yet to come. Now, Mendeleev's periodic table, it was based on the physical and chemical properties of the elements. Okay, and also the atomic masses of the elements. Now, what did he do? What did Mendeleev do? Who can tell me? What was Mendeleev's periodic law? Anybody?
The properties of elements are the periodic function of the atomic masses.
Yes, very good. Thank you so much, Shama. The properties, the physical and chemical properties of the elements are the periodic functions of their atomic masses. Okay. Now, what is meant by this periodic function or the periodicity? Can anyone tell me what is meant by periodicity? Bolo, bolo, anyone, unmute yourself.
They repeat periodically.
Yeah, they repeat periodically. They are like elections. Elections keep coming after every 3 or 5 years, no? This is also the same thing. Something similar, you can say. Okay. The repetition of properties of elements at regular intervals. Okay. It is called as a periodicity of properties. Now, what did Mendeleev do? Mendeleev actually he arranged the elements in the increasing order of their atomic numbers. True or false? Anaga,
False.
what did he do? Tell me.
Increasing order of atomic mass.
Yeah, increasing order of atomic mass. Then how could he overcome this Newland octave limitations? Yes, Namrata.
He kept spaces for the future elements.
He was very futuristic in design. He left space for all the different elements that were yet to be discovered. Okay. And what did he call them? Tanushree?
Eka boron, eka aluminium, eka silicon.
Yes, very good. Thank you. Eka. Eka means, in Sanskrit, Eka means one, right? So he left that one before aluminium, boron, silicon, like that. Okay. So he left spaces for the elements that were yet to be discovered. That was a main contribution that he did. Okay. Then he also predicted many undiscovered elements on the basis of the positions. Okay. And there are people still using Mendeleev's periodic table to correct the atomic mass of some of the elements. People still use Mendeleev's periodic table to correct the atomic mass of some of the elements. Plus, noble gases could be accommodated in the periodic table. Okay, they could be accommodated very easily after their discovery in the periodic table. So these were the main merits, the 4 points. The first point is that he provided empty spaces for new elements that were not yet discovered. Second point, he predicted the properties of many of the undiscovered elements in the periodic table. Then third one, it can be used for correcting the atomic masses of some of the elements which we are not very sure of. Okay. And the last important point is that the noble gases could also be accommodated in the periodic table after their discovery. All right. Then, now these were the good points. What were the limitations? Anybody, somebody, nobody?
Place of isotopes was not explained.
Yes, isotopes did not have a position. Then one more.
The
Hydrogen.
was not clear.
Hello? My voice is clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So another disadvantage was that hydrogen did not have a proper fixed position. Okay. That was one of the another big drawback. So hydrogen in Mendeleev's periodic table, it was along with the halogens and alkali metals. Okay. And there was no place for isotopes. Position of isotope was also not fixed. So the most famous isotope was chlorine. Chlorine 35 and 37. And another disadvantage was, in some cases, there was no the trend in atomic mass was not uniform. Like nickel was after cobalt. Okay. But nickel atomic mass is 58.7, cobalt is 58.9. So it was after cobalt. So that was another big disadvantage. And so finally, again, that did not work quite the way it should have worked, the way people wanted it to work, or rather the scientists of that time wanted it to work. But nevertheless, it opened the doors for a lot of other things. Then, somewhere just before the First World War, okay, a scientist named Moseley, Henry Moseley, he actually showed that instead of arranging all the elements in the increasing order of their atomic masses, if we arrange them using the atomic number, it would be much easy. Okay. So he actually showed that atomic number of an element is a more fundamental property than the atomic mass. This is what was shown by it. This was proven by him. Okay. So then he actually stated the modern periodic law that the physical and chemical properties of elements are periodic functions of the atomic number. Physical and chemical properties of elements are periodic functions of the atomic number. Okay. So what is the basis for the modern periodic table?
Atomic number.
Atomic number, yes. Okay. It is atomic number. So now you all tell me, how did he arrange the elements in modern periodic table and what are the trends? I am not going to say. You all tell me.
He arranged it into 18 groups and 7 periods.
Okay. Then what else, Anaka?
Increasing order of atomic mass, number.
Ade. Not atomic mass. Mass alla, number. Okay. Anish, what else?
Position of isotopes.
Position of isotope. What happened to isotope position?
He gives space for the position of isotopes.
Yeah, he specified the position of isotopes. Yes. What else? Namrata.
There were metalloids, metals, and non-metals, and even halogens, noble gas, etc. They were
Yeah.
arranged according to their number of valence electrons.
Number of
outer group.
valence electrons. Yes, very good. Okay. Kshama.
The elements in the same group have the same valency and have different number of shells.
Very nice. Tanushree.
In periods, he arranged in such a way that valence electrons goes on increasing from left to right. Then
Yes.
they had same number of shells.
Yes, very good. So the modern periodic law is based on the atomic number of elements. Then atomic number is equal to the number of protons present in the nucleus of the atom of the element. Then they contain 18 vertical columns known as groups and 7 horizontal rows called as periods. Right? On moving from left to right in a period, the number of valence electron increased from 1 to 8. And on moving from left to right in a period, the number of shells remain the same. Then the next one, all the elements of a group in the periodic table have the same number of valence electrons. From there, we come to the trend in the modern periodic table. We are only focusing on 5 properties. Valency, atomic size, metallic and non-metallic character, electronegativity. Right? Now, valency, the valency keeps on decreasing, increasing.
First it increases, then it decreases.
It increases and then it decreases. Okay. So valency on moving from left to right. The valency increases from 1 to 4, then it decreases up to 0. Remember, it increases from 1 to 4. Okay. And then it decreases. 1, 2, 3, 4, 3, 2, 1, 0. So which one is having 0 as a valency?
Noble gas.
Noble gas. Okay. Noble gas has a valency of 0. And what about it in the group? From top to bottom, the valency remains the same. Okay, the valency remains same because the number of valence electron remains the same throughout. So valency of group 1 is completely 1. Valency of group 2 is 2. 3 is 3 and so on. And then in that case, what is valency of group 8? Will it be 8? Think about it. Tell me later. Okay. Now, what about the atomic size?
Left to right decreases.
Okay. Left to right, it decreases. Why? It should actually increase, no? Because there are
Nuclear
more
force is
electrons.
more.
Pardon. Please repeat, Anish.
Nuclear force is more.
The nuclear charge is more. Okay. So, it is like this. That as the number of electrons increase, when people are like, they're coming and taking away the electron, and the nucleus is like, I will not give you any of my electron. No, I'm not going to give you even one. Okay. This is what happens there. So the atomic size on moving from left to right, it decreases since the nuclear charge increases. So the electrons, they come closer towards the nucleus. All right. So the maximum electron size, the atomic size will be for lithium, and then it decreases right up to fluorine. Okay. Then the atomic size of noble gas in the period is the largest. Why? Because it has a completely filled electronic configuration. Atomic size of the noble gas in that particular, in whichever period you take, it is the largest because of a completely filled outer electronic configuration, or rather a fulfilled electronic configuration. A fulfilled electronic configuration is the right term. Okay. And whereas in the group, the atomic size keeps on increasing as you go down the group because there are more and more new shells. All right. Since there are more and more new shells that are being added, the atomic size keeps on increasing. So the atomic size in the last group, that is in the, sorry, not in the last, the second last, that's a halogen group. Okay. It is fluorine, chlorine, bromine, iodine. Iodine has got the largest size. Fluorine has the smallest size. So from this, what can you conclude? Fluorine has the smallest size. Can you say something about the electronegativity? What
It has
happens?
high electron.
Fluorine is the most electronegative. Okay. Now, what can you talk about the metallic character? Metallic and non-metallic character.
Left to right metallic character decreases.
Left to right, metallic character decreases and non-metallic character increases. Why is that so? Can any of you give me the reason? Is there a specific reason for that? See, ideally, metallic character is nothing but the tendency to lose the electron. How fast an element, not a person, sorry, how fast an element can lose the electron. Okay. So, now along the period from left to right, the metallic character keeps decreasing because the tendency to lose electron decreases. The first ones like lithium, sodium and all, they are ready to lose one electron. That is okay with them. That's why they have a plus charge. Okay, but when you go to fluorine or chlorine, bromine and all, they are not very much ready to lose the electron. Okay, they are like, I don't want to lose the electron. You give me one more electron, I'll be stable. I'll get my moksha. Okay, that's what fluorine, these halogens and all say. So metallic, the tendency to lose the electrons along the period from left to right, it goes on decreasing. Therefore, the metallic character also decreases. All right. And as a nuclear charge naturally, as a nuclear charge also increases, the metallic character also reduces. Okay. Whereas when you move from top to bottom, again, the metallic character increases because the atomic size also increases. So the tendency to lose electron increases. Bigger the size, more they are able to, more easily they can lose the electrons. Okay. Because for example, it is very simple. There is always a difference between your friend and your classmate, right? If something happens to your friend or your, if your friend starts crying, you get concerned naturally, isn't it? You go and ask, hey, what happened? Why are you crying? Blah, 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 blah. But if one of your classmate is crying, that person is crying, God knows for what. You're not so very attached to that batch, to your classmate, isn't it? Because the distance between you and your classmate is huge. Your classmate is not sitting next to you in the class, is he? Is he or she? No, na? They are sitting far away from you. The distance is increasing. So the tendency to lose electron is also increasing. Now you got the logic. Anagha is smiling. Anagha understood what I'm saying. Huh? Very well. Okay, fine. So moving on, the metallic character decreases as you move from left to right, whereas it increases as you move from top to bottom. All right. Then comes a non-metallic character. Non-metallic, if metallic character is a tendency to lose electron, non-metallic character is just the opposite. It's a tendency to gain electrons. Okay. So in the period along from left to right, the non-metallic character increases because tendency to gain electron increases. And this is more due to increase in the nuclear charge. Okay. The tendency to gain electron increases because of the increase in nuclear charge. So the non-metallic character also increases. All right. Now, this is all about metallic character, non-metallic character, atomic size and everything. Now, you tell me, what about the chemical reactivity of these elements? What happens to the chemical reactivity? Does it increase or decrease, or does it remain the same? Just think, metallic character, atomic size, all these things are done. So what do you think will be the chemical reactivity? No idea? You want me to tell you? Yes, ma'am. Okay, wait. So chemical reactivity, it increases down the group. Okay, because the tendency to lose electron also increases down the group. Now, chemical reaction, I'm not very sure this is there for your exam, but remember it in the long run. Chemical reaction is nothing but losing or gaining of electrons. Always you see this cation and anion being formed, right? Whenever there's a chemical reaction, there's a cation, there's an anion being formed. Why does this cation and anion get formed? What is the reason? Anyone? Unmute. Yeah,
Because
go
of
ahead.
transfer of electrons.
Yes, it is because of the transfer of electron. So this chemical reactivity is nothing but your transfer of electron. So it actually increases down the group because the tendency to lose electron increases. Whereas in non-metals, chemical reactivity decreases down the group because there the tendency to gain electron decreases. All right, that is why iodine is somewhat less reactive than fluorine. Okay, now coming to the electronegativity. Now, electronegativity is something like magnet attracting iron. Okay, so it is a tendency of element to attract the shared pair of electrons towards itself. The tendency of an element to attract shared pair of electron towards itself. And this electronegativity increases with increase in nuclear charge and decrease in the atomic size. Electronegativity increases with increase in nuclear charge. Increase in nuclear charge means what? Decrease in the atomic size. Okay. This much everything is okay. Life is beautiful for all of you, or life has become very complicated. It's okay, okay. Tanushri is like, Okay, fine. We will look at some of the question answers. Okay, because question answers are what is more important in this. And I hope you know how to remember the first 20 elements. You all remember them, I hope. Yes. Which are the first 20 elements? I'm sure you have made your own acronyms. Go ahead, tell me. Yes, Anish, go ahead.
Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium.
Argon, potassium, calcium. Her, he, libepsin of neon. Nam, gal, sits chlorine, argon. K, cap. K's, potassium, cap, calcium. Okay. All right. I remember this is how my sir taught me, but my mom ended up narrating some story to me and I got completely confused. But all her students remember that. I don't know how. I still have not understood it. Okay, anyway, now let us look at some of the questions. Okay. The first question is why does the atomic radius or the atomic radii decrease as you move from lithium to fluorine?
Because of the increase in nuclear charge.
Because of the increase in the nuclear charge due to increase in atomic number. Now, if the nuclear charge increases, then the force of attraction between valence electron and the nucleus also increases. Okay. So the effective nuclear charge increases and the atomic radii starts decreasing as you move from lithium to fluorine. All right. Okay. Now, which one is more metallic? Beryllium or fluorine?
Beryllium.
Beryllium. Okay. Now, if you compare sodium and magnesium, which one is bigger?
Sodium.
Sodium. Why? Why do you think sodium is bigger?
For magnesium, the nuclear charge is more than.
Sodium is bigger than magnesium because it has lesser nuclear charge. So there is a less force of attraction between nucleus and the valence electron. Okay, therefore it is bigger in size. And all right, then how will you distinguish, or how will you actually establish that a particular element is metallic or non-metallic?
By its physical and chemical properties.
Okay. All right. Now I'm giving you one element. Okay. Or rather, I'm giving you just a fictitious element. And I'll tell you that the atomic number of that particular element is, say, 17. Now you have to tell me whether it's a metal or a non-metal.
Non-metal.
Why?
Because it's gain electron.
Why will it gain electron? It already has 17 electrons too.
To form octet.
Complete octet.
Yes. If it is 17, so then the electron configuration will be 287, which means 7 electrons in the outermost shell. That is, it has 7 valence electrons, so it needs one more. So it is electropositive or negative?
Negative.
Electronegative. Okay, so it's a non-metal. All right, good. Now, which were the physical and chemical properties that were used by Mendeleev to create a periodic table? To create the periodic table, which were the physical and chemical properties used by Mendeleev? Think for a minute and then tell me. Unmute yourself and tell me. I won't tag anyone. You all can refer your textbook. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Tell me. So one is, yeah, go ahead.
Among chemical properties, he concentrated on the compounds found by the elements of oxygen and hydrogen.
Right. So atomic mass was used as a physical property. Okay. Then nature and formula of the oxide and hydride formed. That was a chemical property used by Mendeleev. All right. Then he made two very important observations. And somehow he could not explain that observation. One was that increasing order of atomic weight. The increasing order of atomic weight was not maintained while the chemical properties were being matched. Okay, and chemical properties, they do not depend on the atomic mass. They depend on the atomic number, because chemical property is all about losing and gaining electrons. Then isotopes have different masses, but they have the same chemical property. So that he could not explain. So these were the two things that Mendeleev could not explain, and so it became a shortcoming. All right. Now, generally for you in the board exam, the questions would be in the form of comprehensions. Okay. For periodic table, mostly I've seen a lot of question in the form of comprehensions, assertion and reasoning, and MCQs. You very rarely get those big 5-mark answers and all. That happens very rarely. Okay. Now, do you all have any doubts in this particular chapter? Anish has a doubt. I think he was going to and then like, what was that? No, no doubt. Life is beautiful. Oh, yeah. Kshama was like, Okay. So, in that case, I'm basically, see, in this chapter, all you have to remember is understand the trends in periodic table. Okay. How is it that Dobryno classified period? The first thing you should remember is just understand the trends of periodic table. Second thing, how did Dobryno, then Newland and Mendeleev classified the elements? Okay. Remember the drawbacks of Newland's theory. Okay. Remember the drawback of Newland's theory. So just remember these things, you will be able to remember everything else, and you can solve the paper very easily, because mostly they ask assertion reasoning type questions. And yes, some MCQs will be there. Then you will get some tables. Okay, those 4-mark questions, you will get those tables with pre-filled elements in it. They'll say this element A or element D, something like that. And they'll say, now you predict the physical and chemical properties of these elements. Okay, so those will be the kind of questions. And in all those cases, just have a look at the atomic number. Whenever you get such questions, look at the atomic number, write down the electronic configuration. Quickly, you will be able to deduce all the other answers. Because atomic number is the most basic thing for chemical reactions, chemical reactivity, property of all the elements, everything. Okay. If it has 7 electrons in the outermost shell, that means it is going to gain 1 electron. If it is gaining 1 electron, it will always have a negative charge. If it is negative charge, that means it is electronegative, which means it's a non-metal. Hello. Okay. So just remember these things. And carbon has got a slight anomalous behavior. Carbon keeps sharing the electrons with everyone. All right. Carbon has got 4 electrons, so it will take another 4. It will share the 4 electrons with different atoms. Like maybe hydrogen, it may share 2 electrons with oxygen. Something like that, it will keep doing. All right. It's very easy chapter. Okay. I tell you, in your higher studies, if you by any chance take up chemistry, organic chemistry and these periodic elements, they are going to save your life. It is very interesting. Even in practicals, also in higher studies, in the theory also, everywhere it is very simple, logical, and very easy. Okay. All right, then if you don't have any doubts, we can wind up the session. Okay. All right. Thank you, everyone. In case you have any doubts, do shoot us a mail on vidyadanandia@gmail.com. vidyadanandia@gmail.com. Okay. All right. Thank you, everyone. All the best. Stay safe and take care. Eat healthy food.